Welcome to this talk on AI JavaScript rocks. So thank you very much for having me here. While you're all busy trying to figure out how to replace your jQuery applications with Angular or React or Vue, machines are trying to figure out how to replace you. I'm going to show you maybe something at the end of this talk where the first little hint, an inkling of something that can replace you. So, my name is Asim Hussain. On Twitter, I'm JawAche. I blog about Angular and JavaScript on my website, codecraft.tv, and I'm what's called a cloud developer advocate at Microsoft. Sorry, we've had a name change. I'm a cloud advocate at Microsoft. So we're a team of developer advocates, so our job is to connect with developers like yourself all over the world. We each have our specialities. We're all specialists in open source. My speciality is JavaScript, but if you go to that link there, you'll find a list of all of us. There's only about 80 of us right now worldwide. And if you can follow any of us, and we're all available on Twitter, and you can DM any of us and ask us any questions you've got. I'm also an instructor on Udemy. Does anybody know Udemy here? Anybody my student on Udemy? Hi. Nice to meet you. So Udemy added in automatic subtitling earlier on this year, and they correctly subtitled my name to awesome. So my name's Awesome, and this talk is going to be very Asim. And I also very recently, 3 weeks ago actually, just had a beautiful baby boy called Micah. Thank you very much. Thank you very much. That's a beautiful picture, isn't it? Yeah. This is what it's really like, actually, on a day-to-day basis. I'm also, if you look at kind of me over the last year, this is it, or this is what it is. Web development, Asim, machine learning, and I have a really good friend in London called Elna Haprof. This is actually her slide. I stole it. Okay, it's her slide. So earlier on this year, we were just sitting after a long hike, having a drink, and we're both interested in machine learning, and some interesting things were happening in JavaScript with machine learning earlier on this year. So we thought, well, why don't we create a meetup group just to start talking about it? And that's what we did. It's called AI JavaScript London. And things went really, really well with this meetup group. It's grown a lot. There's a lot of interest in JavaScript and machine learning, as this room probably is testament to. And then what started happening was people started sending us links to AI-powered JavaScript applications. And we were like, OK, these are really interesting applications. Let's put them up somewhere so everybody else can see them. And that's what we did. So later on this year, we released AI JavaScript Rocks, AI.js Rocks. Now, it's a website where it's just got a whole load of examples of AI-powered JavaScript applications. They're all JavaScript, so you can always click on them and play with them and be inspired. But each of these different applications have at least a link to the source code, so you can look at how they were built, or like at least some link to some other documentation so you can find out a bit more information about how they're built. So if you're interested in learning a little bit more about AI and JavaScript, you can go here. If you see an application that you like, click on the source code or read the documentation that's associated with it, and you can find out a little bit more. And so in this talk, what we're going to do is we're going to talk about AI and JavaScript by going through 3 applications that have been submitted to AI JavaScript Rocks. I'm going to show you how they work, and then we're going to go a bit deeper in understanding each of them. And through that, you're going to learn a pretty broad spectrum of what's going on in this space. And so you can then decide if it's something you want to get involved with. So the first one, it's a biggie. It's going to change the world. Okay? The Emojifier. TM. It's not trademarked, it's just the Emojifier. So I thought it made sense. Probably should trademark it, actually. And so what the Mojifier does, it takes a picture of a person and can you guess? Can anybody guess? Mojifies it. There's always somebody. There's always somebody. It mojifies it. So what it does is it basically takes an image, finds all the faces in the image, calculates the emotion of the face, the emotion on the face, and then finds a matching emoji and places it on top. Okay? So it's going to change everything. Elon, I've been in talks with Elon recently. I'm going to join his team. But you can find it, you can actually have the Mojifier. I've recently added it as a kind of a proper Slack bot, so you can add it yourself. If you actually go to themojifier.com, you can click add to Slack, and you can add it to your own Slack channel. Amelia? Maybe we should add it to the FrontEnd Connect Slack channel. And this is kind of how it works. So you can basically grab any picture, any random picture in the world, put it in, and it's going to Mojify it. Okay? It can handle multiple faces as well, so you can grab this one, put it in, and it's going to Mojify all of it. Excellent. And it has finally answered the age-old question. What smile is the Mona Lisa? And that's the smile. There's quite a lot going on in this application. It's got quite a lot of different moving parts, okay? But I think the thing that's most interesting about this application is how do you calculate emotion? That's kind of crazy, right? How do you calculate emotion of a face? And what the really surprising part about it is that it's incredibly easy to detect emotion, okay? Just need 2 steps, a 2-step process. The first step is you need to detect facial features. So over the years, we've kind of identified a set of points on the face, which everybody has this set of points, and you can identify these points on a face, on every face. And there's loads of libraries that you can use in order to do that. There's other JavaScript libraries as well that will just take an image and identify the points on the face. Okay, so that's step 1. Just use one of those libraries. And step 2 is even easier, because step 2 you just use a neural network. Okay, pretty easy, as I said. Just those 2 steps, and you're off and running. Do you need me to explain a neural network? Is that? Yeah? Mojify guy, do you want me to explain a neural network? Yeah? Okay, for you. So a neural network is actually has a basis in biology. So this is a neuron. It has dendrites going in, which is kind of just tubes going in. You have a cell body, and you have axons going out. And if enough electricity flows in through the dendrites, if enough electricity flows in, the body might go, okay, there's enough electricity now. I'm going to put some electricity out the other side. That's it. That's a neuron. Nothing else to it. If I asked you to code something like this up in JavaScript, or whatever, you could probably make a pretty good attempt at trying to code something like this up. Maybe class node, an array of inputs, an array of outputs, something like that, okay? And that's all you do. You create something called a perceptron, like a simple neuron. In code, you just have like a node with some edges going in and an edge going out, okay? We're going back into, if we went to university, back into kind of basic computer science. And then we might pump in some values. Maybe these values are the positions of facial features on a face, or maybe house price and number of coffee shops in an area, okay? And then what we do, each of these edges, we just give it a random number. We literally just give it initialize it randomly, okay? And then we multiply them all together, sum them up, and pump them through something called an activation function. It's just a function with some number that goes in and pumps a number back out, okay? And whatever number gets pumped out, you then connect up to another one, and another one, and another one, and another one. To actually understand it a little bit better, kind of looks like that. This is it. It's just multiplication. That's the crazy thing about machine learning. I did a workshop yesterday, I can't remember who the gentleman was, and I was trying to explain to everybody, it's just multiplication. And that's all it really is, it's just multiplication. Just a lot of it going on. But through all this multiplication, you can do some amazing things. So you just multiply those inputs together, times some weights, sum it up, pump it through an activation function, and pump it back out. There's loads of different types of activation functions, and the selection of the right one really matters. But this is just a basic threshold function here. And any value below 0 is 0. Any value above 0 is 1. It's a very, very simple one. There's others as well. There's loads of others. But basically, you just connect all of these together in layers. That's it. So this is kind of a 4-layer, simple feed-forward neural network. So one input layer, taking 3 inputs. One output layer, 1 output. And 2 hidden layers. That's it. Okay? And what you do is you basically, each of these arrows is just a weight. It's just a number that you randomized. It's just a random number that you start off with. And then you have some data that you've prepared previously. Maybe I have 1,000 images that I've gone through and I've said, this is a happy image, this is a sad image, this is a happy image, this is a sad image, this is a happy image, this is a sad image. Maybe I feed as an input, I go through all of them and I feed as an input the facial features of all the faces that I find, maybe just the positions of certain pupils or something like that. And all I'm doing is that multiplication. All I'm doing is that simple multiplication. And at the end, I end up with a number. Maybe I've decided that 0 means unhappy and 10 means happy. I know this image is happy. I know it's probably an 8. I know it's probably an 8, okay? So I know that this neural network right now is wrong. It's wrong. It's off by 5. So we need to change these weights so the next time I pass in that image, it gives me 8. That's called training. When we talk about training a neural network, that's what we're doing. We're just adjusting these weights. And we use something called, a technique called backpropagation. We're not going to go into it. It involves a lot of maths. There's a lot to it. Entire careers are spent just focusing on this, right? But that process of backpropagation, basically, given that it knows it's off by 5, its job is to change those weights so that the next time you pump in the same data, it gives you the right number. Ooh, I'm going to fall over, keep on looking at the screen. Yeah, next time it gives you 8. And that's it. That's what we're doing when we're training a neural network. We're just tuning weights. We're just tuning numbers. That's all it is. There's no other magic that's going on. Just tuning numbers. And then what you do is you can basically, once you've trained it up, you can take that model. They're usually quite big. It depends on the model itself, but they're usually quite big. So you can actually download it and run it in the browser these days. But more often, especially if it's very, very big, you'd probably want to save it somewhere, put it on a server, and then call an API. You know, pass in an image, and the API returns you whether it's a happy or sad number. That's probably what you want to do, right? Especially if the model is quite large. Or you can use an API somebody else has created, okay? And that's what I did for Mojify. So there's quite a lot. It's not just Microsoft that does this. We have a whole suite of products called the Cognitive Services. This is one of the APIs that we have. A lot of providers these days are taking very, very common problems that they've already trained up and making them available to you via lots of API requests. So that was kind of one of the big growth areas we saw last year. And I think this is continuing to grow this year. So that's something you should try out. Although I'm always a little bit weirded out by our picture here on our website, because she doesn't look she looks pretty confused, actually. I don't think that's a picture we should have on the front page of Microsoft, but I don't know who the PM of the website team is, so I don't know who to talk to. And it's actually really, really easy to use. You basically just make a post request to an API, you pass in a URL of an image, and it gives you back a whole bunch of data. This is actually just a subset of the data. So it gives you back kind of obviously an array, one for each face rectangle is found in the image. And for each face, it then gives you an object of data. So it gives you a number from 0 to 1 for anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. Who here's got a beard? Put your hands up. Okay. Unfortunately, I've tried many, many times, and if you've got a beard, you can never be 100% happy. You can never be 100% happy. I've only got to 99% happy with a beard. So I'm just a sad fact. So that's it. So just to summarize this one, Neural networks are incredibly powerful. I mean, we keep on hearing about machine learning and neural networks. We've been hearing about it again and again, especially over the last 3, 4, 5 years. And the thing that's driven a lot of that growth in machine learning is neural networks, okay? But they're incredibly powerful, and they were driving the growth in this space, okay? But the thing I want you to take away is that actually they're conceptually quite simple to understand. Okay, this is an entire career. You can spend your entire career just on this subject. But I explained the very basics to you in about 5 minutes. Okay, conceptually, they're quite easy to understand. First demo done. Next one's going to need a little bit of an explanation. But before that, you've always got to stay hydrated. Especially after last night. Bloody hell. Okay. TensorFlow, MobileNet, and I'm fine. Can anybody read what's on my t-shirt right now? Can you read? Puppies, Azure, and I'm fine. Long story for this t-shirt. It was a free t-shirt for one of our conferences. We were running a workshop in London, and I was wearing this t-shirt one day. And then later on, one of the attendees, Oliver Turner, he created a demo, and he called it TensorFlow MobileNet, and I'm fine. And this is the actual demo itself. So it's just a code pen. But basically what it does, it takes images from Unsplash. And if you look at the bottom, you can see it's actually detecting what's, well, trying to detect what's in the image. Yeah, fur coat. And then, like, hang on, what's the next one? I'm fine is a, okay, maybe not. That's not so good. What about Azure again? What's that one? Fountain, maybe, I don't know. I mean, it could be, you don't know that. Puppies, okay, Terrier, 9%. Could tell. What's the last one? Can't remember. Technically, there's a t-shirt in the picture, okay? All right, so the important thing to know about this demo is that the only API request it's making is to Unsplash for the image. The detection of what's in the image, that thing, that percentage thing there, is happening in JavaScript in the browser. Okay? And it's using a technology called TensorFlow. Who's heard of TensorFlow here? Who's used TensorFlow here? Just a few. So TensorFlow is a product that was open sourced by Google in 2015. And it's a tool that allows you to do, well, a lot of things really, but it's mainly used to do train machine learning models. And it's specifically useful for neural networks, okay? But it's written in C. It's something you install on your computer, okay? But early last year, I think only about 9 months ago, they released TensorFlow.js. New special stuff's coming. Now, the first time I saw TensorFlow.js, I made the initial assumption that it was just JavaScript bindings to the TensorFlow application. So I thought to use TensorFlow.js, you had to install TensorFlow. Okay? That's not true. TensorFlow.js, the browser version of TensorFlow.js, is a complete rewrite of TensorFlow in JavaScript. Complete rewrite, top to bottom. Why is that special? It's special because this is all you need now to do machine learning in JavaScript. This is it. If you're a proper developer, you do the import statement at the top. If you're me, you use a script tag and global variables everywhere. Okay? But this is it. This is all you need. This is the most amazing thing about that. This is all you need to drop you can now drop a script tag in a page and start doing machine learning. Isn't that incredible? Just as a side note, there is a Node version of TensorFlow.js now, which is bindings to TensorFlow proper. So there is you can actually control proper TensorFlow with JavaScript as well. And there's multiple things you can do with it. You can train models. So the thing I showed you earlier on with the tuning of the weights and the optimizer and all that stuff, you can do that with TensorFlow.js in the browser. Okay? But the other really cool thing about it is you can load pre-trained models. Okay? If you can find a model that somebody has created out there and it's been exported to TensorFlow format, you can do tf.load model, or whatever the JSON file is. And that's what Oliver used. He used a pre-trained model that he found on the internet. It's actually called MobileNet. And this is kind of a layer above it, but underneath MobileNet.load, it's just doing tf.load model. And then you just do model.classify, pass in an image, and it gives you back the predictions of what's inside the image. That's it, just like 2 lines of code to do that amazing stuff that you saw. Okay? Now, you tend actually not to use MobileNet for the act of detecting what's in an image. It can only recognize 1,000 different things in the whole world, which is why it probably doesn't do a really great job, to be honest with you. You'd use other services to do things a bit more accurately. But it is very, very useful for other things, such as transfer learning, which I'm not going to go into today, right? But that's what you could do. But as you saw, MobileNet's not that accurate. If you want something a lot more accurate, you use Say Azure. Azure. Yes, thank you very much. Yes, you use Azure. Azure. So again, we have another API called computer vision, far, far more accurate than MobileNet. But this is wrapped up in an API, and it's way too big ever to load on your in your browser, right? And there she is again. She's everywhere. And yeah, there's another demo on AI.js Rocks by my friend and colleague, Sarah Drasner. It's called Dynamic Alt Text, dynamically generated alt text. So she had the idea, wouldn't it be great if you can create, for accessibility purposes, if you can have a website that would just generate the alt text for every image automatically. Okay, so she did a demo of this here. And I just want to show you, zoom into it. Okay, so the top bit is that it tells you a lot of information about the image, but it also gives you an automatic caption for the image as well. So it says a black and white photo of Thomas Edison. The text says, "Hey girl, did we just share electrons because I'm feeling a covalent bond between us?" I don't know. Okay, so I don't really get the joke, personally, to be honest with you. But I think the most amazing thing about this thing is it didn't just detect there was a black and white photo. It didn't just say a black and white photo of a guy. It knew this was Thomas Edison. Okay? And it also got the text from the image as well. So it does quite a lot of things, this API. But she posted it on Twitter, and we all know Twitter, such a friendly place is Twitter, okay? And a few very helpful people pointed out that it wasn't accurate in some situations, such as this one. Pointed out that the caption here was a star-filled sky. The text says for something, right? I don't know, the next one could be true. I don't know. I mean, you don't know though, do you? I mean, it could be. You don't know, right? And I really like the next one because I think we're actually half right with the next one. I think we're half right. Okay. Half right. Half right. I'll take it. 50% success rate. So just to summarize, this is, if you're going to take away one thing from this talk, just one thing from this talk, just take away this. TensorFlow.js doesn't have any dependencies. Okay, you can get started with just a script tag, just an import statement. That's it. Okay, it's a great way to get into machine learning. And MobileNet is another really simple way to analyze images, but again, it's used for a lot of other purposes, not just to analyze images. If you do want to do any serious image analysis, you should probably use an API, such as the Azure Computer Vision API. Okay, the next one is my favorite demo. My favorite demo right now. I love this one. It's called Image to Image. And it's written by a guy called Azaid, who's I think he's in Saudi right now. He's studying. He's a student right now. He's a student. He's still studying at university. What was I doing at university? I wasn't doing anything like this at university. Okay. But he made this amazing demo. I'll just probably show you to begin with. Okay, so you can draw an outline, and then it draws a cat inside the outline. Yeah? This is actually running in the browser. It's actually running in the browser. You can go here and just try it out. Actually, you can go to AI-JS Rocks and try it out. Find the link from there. So it's using a technique called pix-to-pix. Pix-to-pix is the algorithm that it's using, which uses it trains itself up on a set of pictures of cats to figure out how to draw other cats if you draw an outline of a cat. Okay? And it uses neural networks underneath, and it uses what is a fairly new technique. I think it's only been around for like two years, called GANs, Generative Adversarial Neural Networks. Okay? These are amazing, amazing pieces of technology. If you started to see things on Twitter with faces morphing into other faces and other things, they're GANs. GANs, I think, are one of the most interesting parts of what's going on right now. Okay, there's lots of interesting things that are going on right now, but I love GANs. I'm going to explain to you, hopefully explain to you how a GAN works. Okay? So it has two neural networks. We all know neural networks now because we've all taught you. We have two neural networks that are competing with each other, fighting with each other. Okay? We have a generator. Okay, generator's job is to generate images of cats. And we have a discriminator. And the discriminator's job is if it's given two images, it needs to guess which one is a real cat image and which one is a generated fake cat image. That's the discriminator's job. Okay? So the generator takes as input, the inputs that you feed into the first layer is an outline. Just an outline of a cat. That's all you feed in, an outline of a cat. You have a bunch of samples of sketches of cats to begin with. That's all it takes as input, an outline. Then it feeds it through, it does all that multiplication, and it outputs an image. Okay? But remember, when a neural network is first initialized, you just have random numbers associated with all the weights. So the very first image it's going to create is just going to be rubbish. It's probably just going to be noise. Okay? It's not going to be a good cat image. But then it doesn't matter. You take all the images it's generated, you give it to the discriminator, you combine it with real cat images, and you give that all to the discriminator, and the discriminator then has to go, okay, this is a real cat image, not a real cat image, and this is a real cat image. Okay? Now the discriminator is going to be really bad as well, because it's been randomized with random weights. Okay? So it's probably going to do a pretty bad job. Oh, it's cut off. Maybe it says that the real cat image is fake and the fake cat image is real. Maybe it'll do that, because it's randomized. It's not going to be very good at discriminating. So what do? If it's wrong, if the neural network is wrong, you retrain the weights. Okay? You retune those numbers so that one gets better. But then if it's kind of right, okay, then what's wrong? Well, then the generator's not very good at doing its job. So the generator is trained and tuned. Okay? And then it gets better. And so what happens is, the generator just gets better and better and better at generating cat images. The discriminator gets better and better and better at discriminating cat images. And they're just competing with each other constantly over time. And then when you reach the point where the discriminator can't really tell anymore between a real cat image and a fake cat image, you're done. You're done. And then what you do is you don't care about the discriminator model anymore. It's done its job. You take the generator model, and you can export that into a TensorFlow.js format, and you can load it up inside TensorFlow.js with tfload model, and then you can put it in the website, and that's exactly what they did. And then you can just give it your own sketches of cats, and it generates sketches of cats. Okay? That's a generator. That's a GAN. Okay? That's why they're generative. A large part of what we've been doing with machine learning over the years is discriminatory. It's detecting, is this spam, not spam. GANs are interesting because they generate stuff. They generate stuff. All right, that's pretty interesting. It's pretty interesting, but is it useful? What's the point? Generating cat sketches. Is that the point, right? Well, you don't just have to train it on cats. You can train it on anything. Okay? So this is a slightly different algorithm. This is actually vid to vid. So the input to the algorithm is the sketch on the left, and the output is that thing that looks like a real video. The real video is generated from the sketch. Okay? This algorithm doesn't work in the browser yet, but there's always a yet, isn't there, when it comes to browsers and JavaScript. That's interesting, but what about this? One image, different outputs, slightly different outputs. I love it when I make the room go quiet with fear. Okay. But it doesn't. The input, all I've shown you so far is the input of sketches. Okay, but you can actually train a GAN on anything. The inputs can be anything at all that you want. So the inputs could also, you could have segmented images. I'm getting a call from a suspected spam caller. Should I answer it? No. Sorry. So this is a segmented image, so obviously it kind of has some depth knowledge about what's going on. Okay, but that's all that's passed into this one is a segmented image. And then you train it up on pictures of yourself, then you can make yourself dance. Okay? She's not dancing. She's never danced like that before. Okay? You feed in the segmented image, that could be anybody, and it'll make pictures of you dance. Yeah? It'll be the only way I ever could dance as good as this. And it can even work with text inputs. Okay, so you can actually give it text, and it'll generate an image. So you can give it the input to these ones, so this top one. This flower has long, thin yellow petals and a lot of yellow anthers in the center. The images are generated from the text. The first row is after 600 iterations, and the second row is after 1,200 iterations. And the bottom one is actually something that we built. So I have to, hang on, wrong screen. Let's demo this one. Give it a go. Internet gods, please. Yes. Oh. Oops, I forgot. I think this broke this morning. I forgot I wasn't. That's why I didn't put it in. Let's see if it works. Am I missing a Y? Okay, let's give it a go. If it doesn't work in like 10 seconds, I'm going to give up on it. Processing final art. Come on. Come on. 5, 4, 3, 2, 1. Ah. Okay. All right. Well, it also works with images of birds. So this bird is white, black, and brown in color with a brown beak. So it does a pretty good job. I think this one is a bit iffy, a bit weird, but the rest of them are pretty good. Pretty good, right? How far away do you think we are from being able to write in text what kind of website that you want, and a GAN will create the website? How far away are we? I mean, look at this. Look at this. What if somebody has already done it? What if someone's already done it? What if I have created something called FormGAN, where you can type in a description of a form and it will generate it for you? Yeah? Yeah. Should we try it out? Yeah? Try it out. A form with 3 input fields. The first is a number picker. The second is a file selector. And the third is a range. Yeah, we good? Should we give it a go? So that was my friend Sebastian Vitalek. I asked him what his favorite song was in Poland. He said this is his favorite song, Sebastian. Okay, but I got you, right? I got you. Now the reason you fell for that, though, the reason you really fell for that, was because I showed you all this stuff which pointed that we're very, very close to this, okay? I didn't create this because I'm not that good, right? But there are people who are looking to create this, people who can now, you can give it pictures of screenshots of what you want to create, and it's trying to actually then create the code behind it to create the different components. There are people looking into stuff like that. Yeah? Where's my mouse? Oh, here we go. All right, so in summary, so GANs are a type of neural network architecture which learn to generate new images. Okay, they're generative, they generate new images. They take a lot of compute to train, way more than a normal neural network. So you wouldn't, right now you couldn't, well, you can actually train GANs in the browser, but they're not as good as the ones you see right now. You need a lot of compute to train ones that you just saw. But the actual models, the generative model that it created can be small enough to be run in the browser. The cat one, he's got it down to 13 megabytes, which is pretty big, but big enough, small enough to run in the browser, right? A couple of takeaways. If you want to learn a little bit more about how to create, you have to dip your toes a little bit into AI and machine learning, you can go to that link, and it goes to actually a tutorial I've created, which step-by-step takes you to creating basically a Slack bot with like the Mojifier, and you can actually create your own. And just a few final thoughts. Just a few final thoughts on the topic of AI and JavaScript. Okay. So one of the things. So I don't know if I see JavaScript being used now in the academic field. Okay. I don't see us taking over from Python and all this other infrastructure from the academic field, right? But you know, back in the day, we were all just web developers, okay? Now we're front-end engineers, we're back-end engineers, we're UX designers, we're product. As a field grows, the specialities form in a field. So I think there's a future, very near future, where there's going to be a speciality of a machine learning JavaScript engineer, where perhaps you don't need to know, you don't need to sit there and pore through papers and look at the academic research, but you do need to be able to know enough to take a model that's been built by a data scientist, they ship it over to you, and you need to productionize it, make a website out of it. One thing Elle and I found quite interesting was in the meetup group that we started in London, we thought it would be mostly JavaScript people coming in who want to learn about machine learning. But about 25%, 30% of the people who turn up to our meetups are actually data scientists, machine learning engineers that want to learn JavaScript. Okay? Because they've done all this amazing work to make these amazing machine learning models, these beautiful AI models, and they want to make something beautiful out of it, right? So that's why they come to our meetup. And that's it. Thank you very much for your time.